So first thing with SystemC, if you're going in the debugger, is you're going to be distracted by all of the internals of SystemC itself. SystemC has this wonderful scheduler. It's perfect for, discrete event simulation, but when you're single stepping and you could jump into code that you didn't write, and for that matter, it's not supposed to have bugs in it anyway, whether or not it does or not, that's not the issue. The issue is it's not the code you're supposed to be debugging, generally speaking. Also, built-in channels, other people's models, etc. What can we do about that? And another issue, and I'm really not going to address that here, but I just want to point it out, and actually I think you'll have some pretty good ideas on how to address some of this, is something called temporal decoupling and timing annotation that occurs if you happen to be using TLM2. And when you're dealing with that, sometimes issues of time are also a problem. The way you'll probably end up solving that is you're going to have to write some helper methods, and we'll talk a little bit about helper methods anyway in this talk. Another problem with SystemC debugging is, you've got all this parallelism going on here. We have threads, and concurrency is just confusing for a lot of folks. So you need to have good documentation up front showing what you think is going on, have some idea of diagrams showing time interactions and so forth. But when you're doing the debug, you want to know, well, which thread am I in at the moment, right? How do I go to a particular thread, and how do I deal with that? So that's another challenges. And then another problem we have here is performance, the last one I'll talk here about, which is you put in all these things to dump out transactions and all this other stuff, and now you run your simulations, and now someone starts complaining that, oh, the simulation's too slow. Well, it turns out the I/O is part of the reason for it. So we're going to talk a little bit about how you can improve performance at the same time. So if you're going to do debug, you should need to prepare for debug, right? And you need to do preventative coding. That's one of the things I first pointed out. Write your code so that you can detect problems before they show up in the execution. And at least you'll get a message out. Make sure you do really good messaging to explain what's going on in your code. All right. Another thing is, and this is one that's kind of controversial occasionally, which is choose your identifier names carefully. Now, I actually have a pattern for identifier names that I've been using for a while, and it seems to work. And the reason for this naming style is not that I don't know what's a module and what's a producer thread, but when I'm using a tool such as GDB, which has the ability to set breakpoints based on regular expressions, or the ability to filter code names based on regular expressions, then if I choose my names appropriately, it's going to be a lot easier for me to do that. So what I do is I use an uppercase letter, lowercase letters after that, or at least start with an upper lower. I use underscore module on my modules. I know that's a little bit of extra typing, but trust me, this is helpful. And then my threads and method processes have underscore thread or underscore method on them. That really actually helps a number of things. It actually will help you to reading your code on occasion as well. I'm not going to go into the story about it, but it actually does have some other benefits. When you're compiling, make sure that you compile with clean results. Turn on all the warnings, extra warnings, get pedantic, and don't allow any warnings into your code. If you see a warning out of the compiler, you have basically two options. You go fix the code so the warning no longer appears, or you go and suppress a single specific warning in the code, which is similar to fixing it, but you're going in there and you're putting pragma diagnostic and then telling it to turn off the warning around a particular few lines of code. Most of the time, however, what I've discovered is warnings are errors. They're errors that the compilers allow you to go through. They really, in some sense, they shouldn't. And so I want to just emphasize that. A lot of folks have code and it's like, oh, that's just a warning. Most of the time I've seen problems. What I find out is, oh, you ignored that warning and that was not a warning. Talk about that some other time. All right. Next thing, runtime configuration. If you're preparing for debug, how about set up your system so that you can configure some aspects of debug through the command line. We're going to see how I do that, and we'll get into a little bit of that, but that's a really useful thing. Another thing is to be methodical. So if you're going to be debugging something, There are 13 steps. I've talked about this in previous lectures. This one's from the C++ Memory Management webinar, part 3. Some time back, go back and review it. There's 13 steps that if you follow them rigorously, I promise you it'll help you to solve your problems, find the solution to your bugs faster than if you just go at it kind of randomly.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of David's webinar, Debugging SystemC with GDB, whenever you want, by heading over to our website www.doulos.com/od and registering for free. For more free tips and tutorials, visit the KnowHow area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.